We're doing some more review problems today. The first question says, which number is not a solution of the equation? There are several ways that we can solve it. What I would do first maybe is just try to work it out the regular way. What you would do is you would take the absolute value and equal it to itself. Another way would be x plus 5 and then equal it to negative x minus 5. So this one right here, everything cancels, so that's kind of a different kind of question. And on this one, if you add x on both sides, you get 2x. If you subtract 5, you get negative 10. So you get x is negative 5. So I know that that's not the answer because it says which is not a solution. If you plug in 0 right here, we'll find out that that works. The absolute value of 5 does equal 5. So that one seems like that should work. If you plug in 5 here, that's the absolute value of 10 equals 10. That also works. This negative 10 one is the one that's kind of interesting. If you take a negative 10 and plug it in there, you're going to get the absolute value of negative 5. Well, we know that the absolute value is positive 5. But when you plug in negative 10 right there, you get a negative 5. And that can't happen, so this is the correct answer. Let me just show you what this graph looks like, because the graph is very strange. If you put x plus 5, and then how we always try to find the zeros, you subtract x minus 5. And I'm going to go to home so I can see it better. Wow, this is really, really interesting, but the interesting part is that negative 10 is right here, and it's not touching the x-axis at negative 10. But it is touching the x-axis at all these other places, so that's why negative 10 doesn't work. All right, the next one we're going to solve is an inequality. All right, so what we do is, again, put it in Desmos. So let me move this over a little bit so I can see it better. We're going to have the absolute value of, oh, that actually went away, 2x plus 3. And for the 19, you can't just put 19, so we're going to put y equals 19. All right, the question asked me to figure out where the absolute value is greater than 19. Here's 19. Greater is going to be above the line, so I'm looking at these two pieces right here. So it's past negative 11, which means negative infinity to negative 11, and then past 8, so 8 to infinity. The only choices that have the negative 11 and 8 are these last two choices. And I know it's negative infinity and greater than 8, so it's got to be this one. Number 3. It says to evaluate. So I need to figure out where negative 6 falls. Negative 6, is it greater than negative 5 or less than negative 5? Negative 6 is actually less than negative 5, so negative 6 is going to go in that one right there. I would have negative 6 plus 2. This is negative 4, and that negative cancels out that negative. And let's make sure I did that right again. Negative 6 plus 2 is negative 4, and then negative 4 would give me positive 4. Alright, there's another evaluating question here. It says to figure out f of negative 2, and it's a graph. So I go to the x value of negative 2, and I find the y value at that place. This one's open, so it's not that one. It has to be this one. That's at negative 1 for the y, and so negative 1 is our answer. Okay, let's look at number 5. Number 5 is a quadratic formula type of problem. I don't necessarily have to do the quadratic formula on it. It says, which quadratic equation has the factor x minus 2? What that means is that if I look at the graph, that it must have a 0 at 2. It's the opposite of that sign. So I'm just going to graph these and see which one has a 0 at 2. So x squared plus x minus 2. That one crosses at 1 and negative 2, so it's not a. X squared plus x minus That one does cross it too, so it must be B. Number 6, what are the zeros of that function? Anytime it's asking about zeros, we're wanting to know where it crosses the x-axis. So I'm going to go ahead and plug that in. Some big old numbers there. I'm going to press home so I can see a little bit better. So we know it's plus or minus 2. And it looks like there's 2 other choices there, and I can see this one here. I'm going to zoom in a little bit, see what we can see a little bit better. Aha! Interestingly enough, there are 2 zeros that I could not see. Let's click back here again. Negative 0.6 and negative 0.667. So I need to change those to fractions. You can hit the little fraction button here. So I know that's negative 3/5. And that might tell us the answer. This is going to come out to be negative 2/3. You can do it till the fraction bar comes back, and there's that negative 2/3. So we knew it was plus or minus 2, negative 2/3, and negative 3/5. All right. Number 7, if f of x equals that and f of 4 equals 0, which statement is true? All right, if f of 4 equals 0, that means that one of the factors is x minus 4. Well, I could try to factor it and figure out the other factor, or you could graph it and just see if graphing will help you figure out the other factor without having to work it out completely. You could divide to try to figure it out, or I really think this will work. We got negative 1.5 for our other 0. Change that to a fraction, so negative 3/2. That means that we have x plus 3/2. And if you remember, what I've told you is what you do to change that is this 2 sort of multiplies by the beginning. And so you would get 2x plus 3, which means C is the correct answer. Number 8, state the type of number of roots and what type. All right, let's graph it to figure that out. If you have polynomials, you definitely want to graph these because graphing will help you answer many of the questions you're going to look at. All right, looks like we're crossing the x-axis once, and because we're crossing the x-axis once, that means there's only one real solution. That means the other 2 solutions are imaginary. All right, number 9, we want to solve the equation. You can take those choices and plug them in and see which one works. What we have done to solve this is put it into Desmos and move everything to one side. Remember, you subtract it. All right, we'll go to home. All right, there's lots of things that pop up, but the only one I want is the one that says equal to 0. So it looks like 1/2 would work. Another way that we solved this one a long time ago is cross-multiplying. Cross-multiplying may work in a situation like this, but that does help you solve it a little bit easier. Number 10, which of the following is true? So we have this equation and we want to know about horizontal and vertical asymptotes. And our graph will help me with that. So let's continue graphing because it's asking about horizontal and vertical asymptotes. If it wanted to know something about the hole, if there was one, you would need to factor. But because the question doesn't ask me anything about a hole, I think I can figure out what I need to figure out just by graphing it. It looks like I don't see anything like strange going on. I don't see any extra things, so it looks like there's one vertical asymptote here and one horizontal asymptote here. And it just asked how many, so that's all it was looking for, one of each, and so that would be A. I will tell you there is a hole on this one, but you can't figure it out unless you factor, and it doesn't ask about that, so we don't have to worry about that. Number 11, ask the simplest form of that equation. Alright, so what we need to do is we need to factor it. So x squared minus 1, I know that's the difference of two squareds, and if you remember how to do that, I know that I can just do a positive and a negative. And then the next one, 2x squared plus 16x plus 14. Find those zeros. So I know that we would have x plus 7 and x plus 1. Now, something I need to remind you is if there is a greatest common factor, you should always factor it out first. So on top, there is a greatest common factor. What that does is that means that there's a 2 in front of that equation. So we did use the graph to factor it, but technically there's an extra 2 because of that greatest common factor. X plus 1s do go away, and it looks like our answer choice would be A. Okay, number 12 is asking us about the domain. So we're going to graph natural log of negative 6 minus x. Alright, there's sort of what the graph looks like. It's asking about the domain. So I know when I have a graph that looks kind of like that the domain, it keeps going this way, so it's going to like negative infinity, but I need to figure out where it stops here. And see, negative 7 is where it crosses the 0, so it looks like just a little bit more would probably be at negative 6. So it looks like the domain is negative infinity to negative 6. All right, number 13. Which of the following is in exponential form? So we take our base, raise it to the power, equals the number. So this would be 7 to the second equals 49, which means C is our answer. Number 14. You deposit this amount of money into an account with this interest compounded continuously. If we see continuously, we know this is the formula that we're going to use. We're starting with 7,550. Our rate is 0.0725. We don't know the time, and we want the money to triple. If you take 7,550 and multiply by 3, you get 22,650, like that. And there's several things that we could do to solve it. We could take these numbers, plug them in for t, and see what works. We could also solve it like we've been solving our other equations. And just move everything to one side, like that. Find the 0. And so we know it's approximately 15, which our closest is C. All right, number 15. We want to know the solution set here. Although we haven't done one like this in a while, what we did earlier is we did 1/2, and then it says of f of x. So I'm going to put f of x in parentheses in Desmos. And then I'm going to put g of x in as the other equation. Press home and zoom in a little bit. I'm looking for where these cross each other because they want them to be equal. And I look for those x values, so it looks like it is 0 and 4 and 2. And so that's our answer. Let's look at some circles real quick. So number 16, we're asking what x is, and x is this arc right here. I know that this angle is 102, and that angle is across from this big arc, which I know I need to multiply that by 2 to get that arc. And then to get the rest of the arc, I'm going to take 360 and subtract 204 to get the arc that I'm looking for. And when I subtract that, I do get 156. Number 17. Basically, we're trying to find the radius of the circle, and we know that this is tangent based on what it tells me. So we're going to do Pythagorean theorem. R squared plus 17 squared equals 19 squared. So what I would do is I would take 19 and then square it, subtract 17 and then square it, and then I want to take the square root of that, and we get 8.48. Alright, number 18. When we did this originally, we did this by completing the square at this point. I think I'm just going to graph it for you, because I think that you can figure it out by graphing. And you can put all these x's and y's here for circles, and that's really nice. So here's our circle. Alright, our center, so 6, negative 9. 1, 2, so these are going by 2's, it looks like. 4, 6, 8, 10, yeah, 2, 4, 6. So 6, negative 9 doesn't make sense. Negative 9 is going to be somewhere around in here, and then 6, 2, 4, 6. So that seems right. Negative 9, and then negative 6, or positive 9, and then negative 6, because it goes over 9 and then down 6. The radius is not really, I don't have to worry about that because they're all the same. So really this was the thing to look for. And so it looks like our answer is D. Number 19, we have an equation onto some trig, and it wants us to find that period and the amplitude. Amplitude is always the number at the front without the negative, so amplitude is 3. The period is always 2 pi divided by whatever is the coefficient of x, which in this case is 1. So amplitude is 3 and period is 2 pi. Alright, we're trying to find the measure of an angle in a right triangle, so I need to label the sides. This is opposite, there's nothing there, so that side's not helpful to me. This is the hypotenuse, and this is adjacent, so I need adjacent and hypotenuse. That means that cosine of my angle equals 8 over 21. In Desmos, when I'm looking for an angle, this is where you go to the inverse. So cosine inverse of 8 over 21. I do need to make sure I'm in degrees, and I am. So that means that our answer is 67. Lastly, we want to find the radian measure of an angle 110. What we normally do is divide by 180 and then put a pi with it. So we're going to do 110 divided by 180. Change that to a fraction. And we get 11 over 18 with a pi. And then that means that our answer is